All right, y'all, welcome back. Today we're going to be talking about two new types of parallelograms, and we'll be finishing out our section on parallelograms. So we're going to be filling in these last two spaces here. Let's get started. If at any point you feel like I'm going too fast, just pause the video, slow it down, rewatch it, whatever you need to do to make sure that you are understanding the material and getting all of the notes. So, first one of the parallelograms we're going to be talking about is a rectangle. Now, you may be wondering, well, a rectangle, is that really a parallelogram? Isn't that just a rectangle? Well, rectangles are indeed a type of parallelogram, because if I look here at my rectangle and my parallelogram, does this rectangle not have two sets of congruent parallel sides? Well, it sure does. So a rectangle is just a special type of parallelogram with a few extra properties. The main property of rectangles that's important is that a rectangle has four right angles. So a parallelogram with four right angles is called a rectangle. So we're going to go ahead and put that into our picture. All four of these angles are right angles. Okay. Let's jump into the other properties of rectangles. Some of these are properties we already know from parallelograms, so it should be pretty easy. First of which is that the opposite sides are parallel. That one should be obvious. Since this is a parallelogram, that means TA and GN need to be parallel, and TG and AN need to be parallel. Also, property of parallelograms is that those opposite sides are congruent. TG and AN are congruent. TA and GN are congruent. So I need you to fill those in. I'm going to draw them on the diagram first, and then I'll write them down. Those sides are congruent, and those sides are congruent. So we've got TA is congruent to GN, because remember this is a rectangle, and all rectangles have opposite sides congruent. TG should be congruent to AN, and they are parallel. They're opposite sides, so they're parallel and congruent. We're going to go ahead and just fill this blank in over here. We know that all four angles measure 90 degrees, and that means the total should be 360. Because the total of any quadrilateral, the total number of angle degrees in any quadrilateral is 360. Okay. Now with rectangles, we have some other special properties just based on the fact that they are rectangles. So we're going to go ahead and draw in our diagonals so we can talk about those. Let's draw a line from G to A and from T to N. And the first thing that I know about the diagonals of my rectangle is that the diagonals are congruent. They are the exact same. So I talked about those diagonals TN and GA. Those segments are congruent. TN and GA. Now, since this is a parallelogram, I also know that the diagonals bisect each other. This is not new. This is one of the other properties that apply to all parallelograms. The diagonals being congruent is new. That's only true of rectangles, at least so far. But we do know that the diagonals bisect each other. So there is a point in the middle, call that M for the midpoint, such that the two halves of each diagonal are the same. So TM is congruent to MN. I'm going to draw that on my diagram. And I want you to go ahead and try to fill in the other two blanks based on that information. So what other two parts are congruent? Pause the video if you need to. Okay. So the other two parts that are congruent should be GM and MA. And I want to pause for a second and think about what these two things tell us specifically. So I know that the diagonals are congruent. So GA and TN are the same. Well then, since M is the midpoint, I know that TM and MN are the same. They're exactly half of the whole diagonal. Well, I know GA is the same length as TN, and I know that M is the midpoint of GA, so GM and MA must also be half of the original diagonal. So if TN and GA are the same length, let's say they're both 20, half of each of those would be 10, which would mean that all four of these parts are congruent to each other. So not only are they congruent as halves of the diagonal, they are all four congruent to each other. So TM is congruent to MN, is congruent to GM, is congruent to MA. So we're going to have all four of those parts congruent. In the next video, we're going to be talking about the properties of squares, how those fit together, and you might be surprised.